Hello class. This week we are going to explore one of the more difficult topics in C++, and that is pointers. A lot of students have a hard time wrapping their mind around what a pointer is and how it's used. And maybe I think a lot of that might be just from poor explanations about pointers. When I first covered pointers in the C++ class that I took as a freshman back in college, I didn't quite grasp the total concept. I think that the Savage text does a really good job of explaining it. So there's a couple of slides from this week's PowerPoint that I'm going to draw your attention to. I'll bring them up and show them on the screen here. And we'll talk about it. And this video, I'm not going to be doing any of the assignments. This video is just a demonstration of pointer use, how to use a pointer and what a pointer is. So what I want you to do, or what we're going to do here, is we're going to start in the Software Course Docs button on Blackboard. I have posted a CPP file there called pointers CPP. If you want to click on that file, then you can open it with your dev compiler. Okay, a couple of things here first. That system pause function was automatically placed in old dev CPP projects, and it used to just be included automatically. They've moved it into the C standard library. So if you want to use that system pause, C standard library will do that for you. This function isn't necessary in the dev compiler anymore because it stops. The dev compiler will it won't the console window won't self-terminate, and that's the issue with the console window. And within Windows, when it's running within Windows, it usually self-terminates by default, and you have to do something to get it to stop. This was the solution before. If you're publishing an exe file from dev and you want to use that program, you might want to use this function there. But anyway, enough about system pause. Let's talk about pointers. Okay, so what I've done here is I have created a pointer, and the symbol or the syntax of a pointer is putting an asterisk in front of the identifier name. So what that does is that tells the compiler that instead of this being an integer storage location, it is the address of an integer storage location. So in memory, all of the variables that we use, they sit in memory somewhere, and those areas in memory have an address. Just like a DOS pathway is the address for a file that's on your hard drive, this pointer is the address of the variable in memory as it's being used. And so within C++, we can use pointers to variable storage locations. We can use them as aliases to that variable. We can pass those pointers around. And there's just a lot of different things you can do with a pointer, the address of a variable, that you can't do with the variable itself. It gives us a little bit of flexibility, and it gets you intimate with the machine, so to speak. So what I've done here, I've created an integer, or a pointer to an integer storage location, P1, and we set that address equal to, or initialized that address, pointer address, equal to the address of this regular integer variable called x. So here we're just creating a regular integer. We're calling it x, integer storage location, calling it x. That's the identifier within our code, and we're giving it a value of 25. So then that will be created in memory, and x is what that variable is called in your code. Then we can take the address of where x is at and extract it. That's what this ampersand does. And you should have seen this ampersand syntax already. This character was used when we pass by reference. Remember passing by reference versus passing by value in earlier chapters. Passing by reference, what that means, when you pass a variable by reference, you are passing literally the address of the variable, so that any changes made to that variable in the function you pass it to will get made. Those changes will be reflected in the original variable. So when you pass variables normally, or the way we've been doing them typically, that's called passing by value, and those variables will actually get recreated. They create a duplicate storage location. So anyway, this ampersand gets the address of a variable, and then here we're storing that address into this pointer. Okay, and now we're doing some stuff with the pointer. The next line here, I display P1, and if you just display the pointer without that asterisk in front of it, that will actually show the address in memory, and it takes the form of a hexadecimal value. So then if we try to display the pointer and put that asterisk in front of it, that's called dereferencing the pointer. In other words, that means I want to know what value P1 is actually pointing to. And it's just an alias for X. This is the same thing as just using X in your code. So then notice I create another pointer, P2. I set P2 equal to P1. What that does is that gets the address of P1, stores it in P2. So now P1 and P2 both point to the variable X. Now here's where pointers get confusing. Here I'm doing some math with the pointer. I've taken P2 and I'm dereferencing it, and then I'm multiplying that by 2. So this will get the value that P2 points to, which is an integer, which is what P1 points to, which is X, which is 25. And you can see here how it gets a little confusing. We're adding a layer of abstraction here by talking about the address of the storage location. So anyway, I'm multiplying 2 by the value in P2, and then I'm multiplying by 5, and I'm storing that into the storage location that P1 points to, which is really the same thing as X. So this whole confusing statement right here is just the same thing as saying X gets 2 times X times 5, because P2 and P1 are just pointers to X. Okay, so then I display X, I display dereferenced P2, which is the same variable at X, and then I display P1, and then I just display the address of P1, display the address of P2, and then using the ampersand I get the address from X, which is going to be the exact same address. So if you run this, this is what you'll see. So that is the storage location in hexadecimal. That is the address of X, which P1 points to. 25 is the value that asterisk P1 points to, as you can see here. And then X is equal to 250. So once we've multiplied 2 times 5, which is, you're just multiplying 10 by 25 here, which gives the 250. And then asterisk P2 is pointing to 250, and so is P1. Asterisk P1, so they're all just aliases for one another. Here P1 is the address, P2 is the address, and then X's address are all exactly the same thing. Okay, so what's so great about a pointer then? Well, the thing that a pointer allows you to do is when you have large data sets, an array, for example, although you didn't know it at the time, when you create an array, the named or the identifier of that array is just a pointer to the first storage location in that array, in that collection. So when you pass an array into a function, you're really just passing the pointer, and you're telling it where that first first element is, where the 0 element is in the array. So pointers allow us to reference large data sets without having to actually copy all of the data in that data set. And now that we have classes, now that's something that's going to be really important for us. Instead of making a copy of all the data in an object, we can just create a pointer that points to that object, and then that's what we can pass around. So let me draw your attention to slide 28 from the Chapter 9 PowerPoint set. This is describing what I just mentioned about arrays. When you create an array variable, that array variable is actually a pointer to that first indexed element in the array. Okay? A couple of other things I wanted to point out in this week's PowerPoint set. Take a look at slide 41 here. And I'm going to launch the PowerPoint set, that way we can use these links here. So this is an example of using pointers, a lot like the one I just showed you. Here they create two pointers, integer, that point to integer variables, and then they create a new, or they set the first pointer here, p1, equal to a new integer. This is what's called creating a dynamic variable. This variable then it has a pointer that points to it, but it itself doesn't have a name. Remember in the previous slide we had x, in the example that I had you download, the pointers example, I created a variable called x, a regular integer variable, and then I just created pointers to it. Well, you can create a pointer to a variable that doesn't have a name, and when you do that you have to use the keyword new, and that's called a dynamic variable. So here they show you what asterisk p1 points to, and originally they set it equal to 42. So here they dereference p1, so that's getting the storage location that p1 points to, which is currently empty. It's just a new integer, unnamed integer storage location. They store 42 in that location, and then they set p2 equal to p1, so p1 and p2 pointers are both pointing to this unnamed dynamic variable. They display it, so you'll see 42 and 42. Then they change the value that asterisk p2 points to, which again is the same thing that p1 points to. Then they set p1 equal to another new integer, and then they set that equal to 88. And then when they display p1 and p2 this time, now p2 is the only pointer that points to this original integer that we created here, and then p1 now points to this new one. So this is a graphical representation of that. Here are these two pointers, and again, you can think of pointers like variables. They just store an address, a single short hexadecimal address that is the location of some actual variable storage location in memory. So then when they set p1 equal to a new int, that has this p1 pointer pointing to this new int, and then they set its value to 42, and then they set p2 equal to p1, so now they're both pointing to the same variable location. And then here they set p2 equal to 53, so that changes both of them. If we display that p1 and p2 now, they both reflect 53. Then they set p1 equal to another new int, so that creates this new int now. p2 is pointing to the old one, p1 is pointing to this new one, setting its value to 88. A couple of more things I want to show you from this PowerPoint set in preparation for the assignments we'll be doing together in this chapter this week. One is typedef. With that whole asterisk scenario, things can get really confusing. There is a keyword in C++ called typedef where you can define a new thing and give it a name. So what we can do is we can create, for example, our own definition of what an integer pointer is and call it int pointer. So here, keyword typedef, and then they put the asterisk out in front of int. So I want to define all integer pointers with this name, int pointer. So then now in your coding, if you use this definition that you created, int pointer now defines an integer pointer, and if I use int pointer p, then that is the exact same thing as this, creating an integer pointer called p. So this helps with the confusion of the multiple asterisks. Okay, so here for example, by accident, if you don't put the asterisk in front of one of your pointers, asterisk p1, that's going to be a pointer to an integer, but p2 is actually going to be an integer variable. So that dereference there only refers to the p1, not p2. So doing this, however, using that type def, then here it's just an easier way to create pointers without having to use the asterisks. You fold that asterisk into your own personal definition here of what of an integer pointer. Okay, a couple more things. Back to the idea of a dynamic variable. We looked at that example where we created in the slide here, slide 48 I believe it was, where they created slide 43 here where they, well, I'm sorry, slide 41 here where they created this dynamic variable. Creating those variables, those are created in an area of memory called the free store. Let's go back to slide 16 here. There's an area of memory that's used specifically for these dynamic variables, and when you use that area of memory, the variables you create there will just be sitting there until you actually tell C++ to delete it. Now this is something that modern languages take care of. It's called garbage collection. Visual Studio and Java and most languages have garbage collection built in. C++ does not. That's another one of the things that makes C++ one of the more difficult languages. You as a programmer have to be aware of this. If you don't delete these dynamic variables that you create in memory, they will be sitting there in memory. And so if you've got a server, for example, running a program that is is constantly running, it runs all the time or on a loop, and it creates these variables in memory, and you forget to delete them at any point, then you have what's known as a memory leak, and those dynamic variables are just sitting out there in memory, and eventually all that memory will be used up. And that, I believe, is what the next slide talks about. If you delete the pointer to a variable but don't actually delete the variable, it's sitting there in memory, and it's you've got this dangling pointer. Going back here to slide 16 again, if all the free store is used up, any calls to a new variable, trying to create a new dynamic variable will fail. So this is something you have to be careful with when you create these dynamic variables, these unnamed variables and all you have is the pointer that points to that storage location by its address. You just have to be careful. Delete is the keyword to delete the pointer, and P right there is the pointer that you're deleting, which will delete that actual storage location. Okay, last thing I want to talk about in preparation for our first guided practice is the idea of a dynamic array. And here's the concept. Let's say I create an array where the elements of the array are all pointers. So you can create an array, and here this array is called M, and every element in the array is an integer pointer. And that integer pointer, or actually it's a pointer to a whole nother array. It's an integer array pointer. So each element in the array is pointing to a whole individual array. So you get this really complex data set here. And we're going to use this in our first guided practice. So I'll reference this slide again in the next video when we cover that. So pointers is definitely an interesting thing. Using the actual address in memory, it gives us control over sending and receiving, basically the movement of our variables through our program. It makes it easier. So make sure you cover all of these PowerPoints, and I would definitely read the textbook. There's also some good online explanations of pointers. I have one up here, www.c++.com. You can look up pointers here. I'll put this link on Blackboard so that you can read through this article, and hopefully it'll shed a little more light on the subject of pointers if you're having trouble understanding them. So, happy programming, and I will see you in the next video. Make sure you know yourself.